Okay, now we're back live.
Okay, so we're back live. I was explaining the. No, we're not live.
No, don't do that. Please don't play it loud. Okay, will it repeat me? Good. All right, excellent. So we are recording and it's not speaking aloud with a delay. Right. All right. So yes, I know why. Because when I'm streaming, I actually have to have a preview on for some reason. It didn't allow me to start streaming without the preview on. Okay. So I was explaining here the wiki problems which we had. So that's sorted. So we can go to the class and wiki. And today we're gonna discuss the. Oh crap! I didn't link the lecture slides yet. So the lecture slides here. All right, so user interfaces. Why do we have a whole lecture about it? Yes? Lights off. Better?
Yes.
Great. Okay. So yeah, the first line is no, that's not the first line. But on the second slide, that there is a line saying the UI and UX is a huge topic, and we should spend the entire course. And in fact, there is a user experience bachelor degree where you can spend the whole 3 years discussing all those things, right? So in a kind of a short lecture, I am not able to tell you everything, right? I will tell you some basics and I give you some pointers, but those of you who really want to dig a little bit more into the user experience side of things, they have to do their own sort of research. So user interfaces is pronounced UI, and then you have the other one called graphical user interfaces, which is sort of pronounced GUI, right? And it's kind of funny because the GUI pronunciation is sort of more driven by Europeans speaking the consonants the way they are written, not the English, right? So English speaking person wouldn't pronounce GUI as GUI, but it kind of stick. So even the English speakers are saying GUI. So what is it? It's the interface between the user and the machine, right? So we had kind of two terms before. We had HMI, which is like human-machine interface. So the interface between a human being and the machine, and the machine-to-machine interface. So that's how the machines kind of operate together, how you interfacing one machine with another. Those terms come from that era where it was all physical. Now we sort of shifted to more of a digital sphere, and then we have some other terms, right? So we have a command line interface. So that's the one which we used, for example, in the cloud course for talking to Heroku or talking to Google App Engine. We have the GUIs. You may see somebody referring to the web user interfaces. And we have interfaces now which are kind of requiring touch, gesture with camera tracking or kind of on a surface, and motion tracking, which are done usually with the depth cameras to kind of track what you're doing, like Kinect is an example of that. So there is a plethora of different terms and different user interfaces which are kind of in between a human being operating a software system or operating some sort of application. So yeah, that's the line. UI is a huge topic, and the design became kind of a topic on its own. So user interface design and user experience design became a topic which renders their own field of study. So we have the bachelor degree in user interface design or experience design. So why do we have user interface and user experience as two terms? Why do we have two terms? Any idea? So user interface, if you look historically, that's where it kind of started, right? It was sort of the interface between the human and the system. And we still have it between like physical items and humans, right? But it kind of became apparent that you know, it's not about the interface as such. It's more about how it is being used and how it is being operated. So the user experience term kind of captures and encompasses both the actual layer of interfacing and how it is being used and what it creates, what sort of mental models and how the user kind of interacts with that interface. So we use metaphors, we use a lot of different mental models of how things should be operated, and we take advantage of the biases people have and the way physical objects are being moved around. So, you know, even like the mouse, we take it kind of for granted these days, but when you had the first computing systems and you had the kind of a concept of the cursor and moving the cursor around, that was kind of very difficult to come up with, right? We had textual interfaces where you have text on the screen, you have a particular dimensions of like, you know, 80 characters wide and 40 characters in length or something like this. And then you have interfaces kind of operating this way. And then you have a kind of a character cursor, right? Which you can move column by column, now line by line. So in the normal text editor, you can move the cursor right to the end of the line, but not further, right? There were some editors where you can move it freely in the kind of rectangle space. And that's where the idea of graphical cursor kind of came about. But then how you move it around. So, you know, coming up with the mouse and how it is being controlled, like we feel it's natural, like everybody knows how to use the mouse. But when I was trying to tell my sister, like my younger sister, how to operate the mouse when we were kind of playing kind of early computer games, yeah, she couldn't get the concept, right? The coordination, eye, screen, and hand coordination was kind of not that obvious to her. And it you know, we take it for granted, but it's not very natural thing to do. Like dragging a finger on the screen and dragging the cursor now with a tablet, that's much more intuitive and much more things that everybody understands. So all the kids understand that automatically, right? But the mouse, that's a different story. So, but you know, some things became ingrained and some things are kind of done a certain way because we all understand it from early age to do it. So we have, you know, some limitations. We have size limitations, the concept of scrolling things, because you have a limited viewport of how much you see on the screen. So if the content is wider or longer, you can kind of move the viewport up and down, right? So that's also kind of a metaphor. Like if you imagine that you know, if you have a page which is longer than what you see, right? And you have this viewport, right? So what do you move? Do you move the viewport up to see the upper part? Or do you scroll the content down to see the upper part, right? So, you know, that's where the switch happened, like few years back, where the scrolling of the mouse changed from scrolling the viewport to scrolling the content, right? So like when I place my finger on the page and I drag my finger down, it looks like as if I have touched the page and I'm dragging it down so I can see the upper part, right? So scroll down means looking up, but you know, before scrolling down means actually seeing the bottom part, right? So it depends, like it depends how you work. And some of you are using the old model where scrolling down means watching the down thing, and some people are switched and they see scrolling down as watching the upper part, right?
doing the opposite thing of what you used to. So gross and weird is like
exactly. And then if you sit in a computer which does the opposite to what you used to, it's like, what is this? Like, why the scroll works the opposite, right? But both groups of people are very familiar, and like it feels natural to them to do either this or that, right? Especially if you're dragging the scroll bar. If you have the, if you have the page of text, and if you have the scroll bar here, that feels very natural to both groups, right? And very unnatural to the opposite group, right? If I place the finger here and I'm dragging up or down, then it feels much more natural to use one of those two models, not the other, right? Because if I put my finger here and drag it down, I don't expect to see the bottom part of this document. If I wanted to see the bottom part, I would drag my finger up, right, to see what's here, what's hidden. But with this, it's 50-50. I mean, it's not the same. So there are some things that you have to pay attention to in general. Here we try to focus only on mobile, right? So what we have specific to mobile? Well, we have the screen sizes, so limited real estate and different density of pixels. We're gonna discuss it in a moment. We have the ability for the user to move around, so the phone kind of goes places, and also you don't use it in a kind of a fixed position. You're interacting with the mobile phones mostly by touch. There are some interfaces which use camera, which are using voice, but predominantly it's kind of touch driven. So here we focus mostly on the touch. And then you can use the context of the world around you to kind of become a part of the interface as well. So when you played, Pokemon Go, the world around you was sort of the playground, right? It was not all on the phone. It was you have to move places physically to interact with the game world. So there are specific things depending on what exactly you're doing. Those are kind of examples of input and output things that work as the interface, right? So we have keyboard. Keyboard is a good entry point, right? You have click via touch, click or tap. You have potentially wheel or trackball. I was showing you the kind of a trackball phone back in the day, one of the HTCs with the trackball. Nowadays we don't do that, but it is a possible kind of input device. You have your sensors being kind of the input as well, because you can control them. Like you can use the accelerometer or gyroscope or the GPS, for example, in Pokemon Go. And there are kind of multi-gestures and gestures that people are coming up with. So in the research paper which we're doing for the master students, we are discussing, for example, a paper which was using gestures for editing text, right? So normally when you're editing a message, let's say you're editing a text message on your phone, and you have the entry field, and you start typing stuff, and then you want to delete a word, right? So let's say you want to go here and delete this word. So what do? You have to sort of move the cursor, and you have cursor here. You have to move the cursor somehow, fit it exactly here, and then you press the backspace a few times to delete the word, right? And editing that, it's kind of inefficient. And also if you want to insert the word somewhere, you have to do that with particular, moving the cursor here and typing the new word and pressing a space, right? But if you are here and you want to move few words back, maybe there is a gesture which moves you word by word backwards, right? And maybe there is a gesture which deletes a word, no matter where you are. So if the cursor is here, no matter where the cursor is, if you do this gesture, it will delete the word where the cursor is, right? So you can come up with an interface which very streamlines the way you edit text on the mobile device, because it will use particular gestures for operating on the text, right? And they've done the study of whether people knowing those gestures are more efficient in editing messages than people who have to use the currently traditional method of dragging the cursor around. Even with dragging the cursor around, you already have two metaphors. So those of you who are using Android, how do you move the cursor around? So obviously, if I have a text message here, and the cursor is here, and I place my finger here, I will hide part of the screen of where the text is and where the message is, right? So what will happen on Android device? Yeah?
It shows you on a separate tiny little viewport what's happening under your fingers, since you can't see that area of the screen. And it shows you where the cursor is and you can move it.
That's what happens on Android?
Or is that iPhone? I don't remember.
That's iPhone, yeah?
The use of toggle under the...
Exactly. So on Android, you have kind of a bubble here, which you can drag around, and you see where the cursor is exactly, because you're not hiding the cursor, you're kind of using the bubble under the cursor to move the cursor around. On iPhone, you place it where the cursor is, and then you have this kind of a pop-up showing you exactly of where the cursor is, because it kind of magnifies the bit which is hidden under your finger, right? Already you have two metaphors. Which one is better? Well, you know, both work, right? Half of the people are very familiar with one and half with the other, yeah?
I've used Android for over like 2 years now. Since I last had my phone, I haven't noticed that anything is different.
Exactly. You see, so it's kind of efficiency-wise and performance-wise, it probably doesn't matter, but it's just completely different metaphor of watching of allowing people to manipulate the cursor, right? Okay, so then and microphone is another potential input source, and there are some interfaces which are kind of using that. Camera is another one, yeah?
I have a funny story from yesterday.
Okay, good.
How fantastic this input method is. I reinstalled Windows and in the new feature update, the first thing that happens is Cortana wants to set up the computer with you.
Yes.
So with my friend talking in the background, it heard something other than just me saying Norwegian.
Yes.
And it then installed Swiss computer layout on my computer. There's no back button.
That's broken.
It's fantastic.
Yeah. So there is a lot of funny videos of people interacting with Cortana or Siri, where someone in the background kind of talks to the device and makes it do something that the original user doesn't want to happen. So it is possible to have some mishaps if you're using the microphone. All right. So what do you have as an output? How the app and device give you feedback? So one is screen, obviously, right? You have the UI, you have the user interface as a graphical interface showing you stuff in terms of windows or gadgets or widgets or stuff like that. What else can you do? So there is kind of you can use vibration, right? To give kind of haptic feedback. And we all know, like, pressing a button kind of vibrates the phone a little bit, so you press the button, right? But that's trivial. There was an app which was a notification for your inbox, right? So how many messages you have in your inbox. And normally when you pull out the phone, I don't have a phone here, but yeah, if you pull out the phone, usually you have an icon and it tells you, oh yeah, one message or no messages, no new messages. Oh yeah, you have a sound as well, right? So sound, music, number 3. But if you're on the meeting and you want to check how many messages you have, how would you do that without pulling your phone and opening the screen and checking it, right? So the idea was that you can have a metaphor of every message being like a ball, being kind of in a box of, so you have kind of a three-dimensional box. And if it's empty, it means you have no messages, right? And you can shake the box and check if it's empty. If you have one message, there will be one ball inside. So if you shake it, you will have like one ball bouncing around and you will feel, okay, I have just one message. If you have two, you will feel, okay, it's more than one, it's probably 2 or 3. Like you can distinguish between, few and like a lot, right? If you have like a lot, then if you shake it, you will know that there is a lot, right? So it's kind of a haptic interface for counting things, yeah?
If you already have enough free space to shake your phone, do you not have enough free space?
No, you can shake your phone in the pocket. Mm. Right. So what else? What else can you use as an output? I don't know. Yeah.
You have tiny lights. It's not like they're on top of it.
Good. Yeah.
With different colors.
Exactly. So you have a tiny LED, which usually you can program of what it means to have a different color and also like different pattern. You can have a certain blinking pattern for telling you, communicating with you.
It can get, depending on the type of phone you have, it will get hot depending on what you do. So it's fun to output as well, I guess.
That's true. Yeah. So, I mean, with the current phones, you're kind of limited, yeah, to the LED, to the, screen and sound and vibrations that we have. There are some devices where you can drag your finger over the surface of the phone, and it will vibrate to simulate a particular texture which is simulated under the fingertip, right? So you can kind of simulate a very smooth one where the vibrations are almost non-existent, and you can kind of simulate like a wood or kind of a sandpaper kind of thing, right? So you can kind of make the texture feel being perceivable by the fingertip, right? It's a combination of the touch screen where you detect of where the finger is and how much it's pressing the screen, and the vibration. So the new iPhones, they also have the sensing of how much you're pressing, right? You could simulate that with the old phones, because if you press lightly, the area that you're pressing is kind of very small, and then if you press harder, the area of your finger kind of pressing on the center of the press point gets wider, right? So you can kind of detect that, but you need hardware to be able to tell the operating system that is what's happening, right? You actually don't need to bend the, if we look at the side, when you're pressing hard, you don't actually bend the screen much to detect how much, force you're applying. You can kind of do that by calculating, okay, how much of a finger is pressing, right? But the new iPhone actually does that a little bit as well. They have sensors which kind of sense the amount of force being applied at particular resolution of the display. So that the technology is evolving. Like again, sky's the limit. We don't know everything which will happen, but we can imagine certain interfaces which take advantage of the senses that we have. And sense of touch is one that we have, right? All right. So what problems do we have? Some of the connectivity that we do with mobiles require network, so that's fine. We already discussed that. The lighting also changes, so we need some kind of good color renditions and taking care of the lighting of the displays. And there are some environmental issues. So, like for example, in the last year project, there was a project of controlling the screen. So you can press buttons without actually touching the phone. Okay. So imagine that you put the phone in the garage, and you are kind of a car mechanic or of some sort of person who works with really dirty hands, and then you need to do something on the phone. And then if you grab the phone with your gloves or with the hands you have, you would kind of make it unpleasant, right? So you would like to be able to click something that whatever, but in the air. And the project was basically using the camera and kind of navigating where your finger was in the viewpoint, and kind of when you did the kind of a click motion, it was kind of detecting it as a click on a particular area of the screen, right? So you could kind of, it's sort of like a, multi-touch kind of gesture detection in the air with combination of the normal touch screen. And then also, like, you can lose your device, and then what? Most phones, first of all, for security reasons, you can wipe it. So you can, if you have your account connected, you can usually wipe the content of the other phone, of the phone which got lost and got connected to the network. There are some strict security rules to prevent kind of a data breach, which we've heard a lot about Apple, like not releasing some of the things to the FBI upon request. And and so on. So there is hard encryption, for example, for your storage on the device, and if someone tries to break in the password too many times, then there is a hardware trigger which actually wipes the data, and so on. So that we are kind of improving in that respect as well. And in terms of backup, we usually have our accounts and phones plugged into the cloud storage. So then if you buy a new phone, you just configure it with the same account, and in a few minutes or hours you have everything as it was on the old phone. So the backup is kind of more or less seamless. So here we will focus on the UI and on the screens and on the real estate. I will talk for another 5 minutes and then we'll have a break. So with different devices, we have some challenges. So one challenge is that, first of all, we're dealing with devices of different screen sizes, okay? So you have physical devices like this watch, which are kind of tiny. You have, I don't know, 2 centimeters by 2 centimeters. We have phones which are slightly bigger, and we have tablets which are even bigger. And then in the phone space, we have phones that are, they look kind of the same, but this one is, 10 times the resolution of this one, right? So it has 10 times more pixels than this one. Physical dimension size, they're kind of the same, right? So now when you're designing a user interface and when you're designing a button, there are some limits, okay? So you, for example, with this open mockup platform, which we discussed lecture ago, you had a screen which was taken from Linux, and when you draw, I don't know, 40 by 20 pixels button on that phone, it was really tiny, right? And you had to move with a very tiny cursor to click on a very tiny button, right? On a normal desktop PC, it was kind of a normal size, and you move the mouse, which also looks normal, and you press it, right? But on the mobile device, when the button is too small, you can't physically maybe press it or distinguish it because your finger is too fat, right? So there are some physical limitations of how big certain things need to be usable for an average person, right? You all relatively young and you kind of skilled, so you can kind of precisely press even tiny kind of places, but you will have limits as well. But if you take an average person with average size of fingers, and they need some sort of average guideline of how big the buttons need to be in terms of physical space, right? So the pixels don't matter. What matters is that the button is not less than, say, 1 centimeter, right? If something is half a centimeter, it becomes kind of harder. It may be an icon, but for a button, it may be too small or something, depending on some guidelines, right? So how would you do that? Well, we have 2 concepts. So first concept is that Android generalizes everything into groups, into categories. So when you're programming your app, you are saying, I'm programming it for a kind of a normal device, and then if the device is extra large or extra large, I want this different set of assets to be used, okay? So for a normal phone, for a normal screen, I may have a button which is about 1 centimeter long, and that means that, I don't know, I'm just kind of guessing here, I may have, let's say, 80 pixels in this dimension, right? But for a phone which is large, I will have 1 centimeter button which has 200 pixels in this dimension, right? What does it mean? Well, it means that if I have an OK, it is the same, no problem, right? But if I have some icon, right? If I have some sort of image or some icon, with 80 pixels, it has to be kind of coarse-grained. It has to be very symbolic. Whereas with 200 pixels, I have more space to do more nuance, more detail, right? So I can differentiate my assets into phones which are more rough and assets which are more detailed. And with the more and more resolutions coming in place, the norm shifted way to the right. So now we have, extra large and extra large and extra large, because the resolution is so packed. We have so many pixels per inch that the screen, even though physically it's the same size, it's 5 inches, it is packed with pixels, so you can do a lot of detailed imaging if you want to, right? So that's one concept. The second concept is, if you program your UI using pixels, you will have those issues that, if you design your button to be 80 pixels on the phone which has, I don't know, 480 pixels, that occupies one tenth of the screen, right? But on a phone which has 5,000 pixels, then it's 1/10 of a screen, right? And the physical size is the same, right? Maybe it's like 4 centimeters. So operating on pixels doesn't really tell you how it will look like on the phone. So what Google did, they kind of decided, okay, let's have something which is pixel resolution independent, and they call it yeah, it's not here. It's called DPI. So device independent pixel, right? So DIP or DP. So in the older Android, it was called DIP. And the new one, they simplified to like device independent pixel, right? And that's sort of a concept of a pixel which has, roughly speaking, the same size regardless of the resolution of the screen. So if I say my button is 80 pixels long, it will vary widely depending on the resolution of the phone. But if you say my button is 40 dp long, then it will roughly be the same size, physical size, regardless of the device that it is put on. The translation between the dp and the actual pixels will happen automatically, right? So this is kind of fundamental concept of why, when you're specifying the sizes of your things for mobile, you're trying to abstract yourself away from the physical reality of the actual density and resolution of the screen. All right, so let's have a break, 10 minutes. Let's go back. Whoops. Issues. Okay, so yeah, device-independent pixels and the different generalized sizes for the screens. So also we have the orientation. So sometimes, you know, in the portrait mode, you have kind of a narrow but wide, long viewpoint. In the landscape mode, you have the opposite. You have kind of a shorter but wider. So if you, for example, want to present the list, you can do it kind of in the portrait mode very easily. And in here, you kind of, your list is a little bit, you know, shorter, but you have more space, so you can potentially do two lists. And it also matters whether the user is using the app this way or this way. So you can, you know, you have a choice. As a developer, you can say, my app has to be used in a portrait mode because most of the data flows this way, and the landscape mode is not existing. Or you can say, the app works both ways, but in this way, you have kind of a more like two columns, and in this way, you only have one, right? So it's, again, depending on the nature of the app and what you're doing, you sort of make the decision. In most phones, you can have landscape and portrait upside down, and landscape upside down, right? So you have kind of 4 different orientations. Some apps don't allow you to use the portrait upside down. You have to, if you're using portrait, it has to be normal, but some apps don't care. So again, it's up to the developer to sort of decide. And then the resolution, of course, is there. The resolutions are kind of important when you're dealing with assets, like with the backgrounds and with the button backgrounds and things like that, because you have to align what your resolution of your existing assets are to the sizes that I was talking about in terms of independent pixels. So if you're doing something more advanced, you can look up the particular resolution of icons and assets for the particular screen with the particular device-independent pixel sizes. So then you know how to prepare your assets accordingly. All right, so with the low resolution, we discussed that in one of the previous lectures. We had this concept of the kind of a main screen, and then you can fork, you know, you can go to particular different screen and then do one thing at a time. So this traditional mobile design comes from, you know, SMS interfaces. I don't know whether you ever interacted with service using SMS kind of interface or WAP. Do you know, have you seen WAP before? So WAP was sort of like a web interface where you had this feature phone interface. So let's say this is the screen resolution of your feature phone, and I don't know, you have 10 characters wide and like 4 characters this way, right? That's your screen, right? What can you do with it? Well, you can browse the web, actually. The web just needs to be organized in a certain way to kind of be able for you to scroll and read stuff on it, right? I'm kind of exaggerating. Maybe it was, you know, 20 characters, right? But the point is that you had a very limited real estate, and you have to show something, and there were websites which were built in such a way that if it is accessed from a web browser of a feature phone using web technology, it would render the content in a particular way that you can interact with it. You can read the content and click on the buttons and kind of navigate your way around. So I actually did that. I was programming like style sheets, which could render the content of the page depending on what was the device which was browsing it. So you have 240 pixels wide interface with 120 pixels this way, and that's it. That's all the real estate you get. So it was very restricted. You have to do a lot of scrolling, and to prevent people being annoyed by a lot of scrolling, you kind of split stuff into screens. Then modern phones came about, and this is kind of a historical slide, right? We say medium-sized devices, Java 2ME and Symbian, it's almost non-existent. I mean, Symbian is dead, and Java 2ME, nobody really programs that anymore. You have a full-featured Java on Android, and you have a full-featured Java on most of the devices that we use, even the Wear, Android Wear. We don't really use the limited device profiles, although you do have them on some of the embedded systems, right? So J2ME is for Java. What was 2 for? Java 2 for mobile edition. Yeah, exactly. So Java 2, by the way, is 1.2, right? So Java 1 was, Java 1 was just normal Java 1.1, 1.0, and 1.1. And then when Java 1.2 came about, they renamed it to Java 2, right? So Java 2 is from 1.2 onwards. So 1.8 now is still called, you can still say Java 2, although some do say Java 8. Yeah, so high resolutions, high size devices, iPhone, Android phones, both those are dead now as well, and tablets and TVs. I mean, very high you have in the phone range now as well. You can 4K phones, on 5 inches you have 5K resolution, right? So it's extremely dense and extremely small pixel sizes. Okay, we've seen kind of a migration from physical keyboards. Like I showed you historically some early Android devices with physical keyboards. You almost never have that these days. And also the physical buttons are disappearing, right? When I got my first phone without the physical home button and back button, I was kind of disappointed. I felt they lack something, right? And now iPhone is also dropping the home button. So iPhone historically always had one button, physical button. They even dropped that. So Android had 3. They dropped that for the virtual buttons. And now we basically have mostly phones with virtual buttons. Why is that? Well, because it's programmable. If you have a physical button, you can't do anything with it. If you have virtual buttons, you can program them. You can make them look different. You can make them do different things depending on the context, and it's communicated to the user. If you have a home button, which is physical button, it always looks like a home button, and it cannot be communicated that in this context, this home button does something else, right? Whereas if you have virtual buttons, you can modify it, you can change it, and you can hint to the user that in this context, this button does this, right? The button which is here in the middle will do this, right? Yeah, the kind of a famous one, I don't have a screenshot, but the famous one is the camera app on iPhone, right? So you have a camera app which shows you a kind of a picture, right? So you have a preview here, and then you have a kind of a round button to take the picture, and then you have the round button which is your home button, right? And if you see that interface is like, if you show it to anybody who never seen an iPhone, we would say, why you have those 2 buttons? Why I cannot press this to take a picture, right? So now you don't have that problem, because if the physical button is gone, you only have virtual buttons, then you just program that, okay, the button in the middle, if you are in the camera preview, will take the photo, right? Okay, we do have a lot of front-facing cameras now as well. So you can do stuff with that. You can do eye tracking, you can do emotion detection, you can do kind of a lot of things. You can change the angle, how you render content, depending on where the person is. And you see that sort of with some user interfaces being used. All right, so let's go on. The bottom line here is that each platform has its own quirks. And each platform has its user base, which is used to doing things particular way, okay? So as we were discussing earlier, if you have a user base which is used to using the cursor with the bubble under it, and you suddenly make them use the cursor on top of things, it will be a little bit confusing, because when I have to move my cursor on Android, I always press the button under the text that I want to manipulate, not on it, right? On iPhone, you have to press on it. So if you have to understand which group you're programming for and what they are used to. So this is one of the reasons why web apps are kind of not liked by users, because the web apps are for the web. On the mobile phone, I'm used to the particular feature of the phone that the phone has. So I like the widgets. I know, not necessarily like, but I know the widgets. I know how they work. I know how they look, and I'm kind of familiar with it. If you show me a different interface which uses web widgets, it's something different. It's something new, right? So most apps which are kind of web developed, not as liked as the ones which are natively developed for the particular platform, and the ones which are developed cross-platform are not as much liked as those we developed for the particular platform. So here we have we have some general guidelines which are kind of cross-platform. So like, pinch to zoom, swipe to scroll, and so on. But even with swiping, we've already discussed, like, if I'm swiping up, what does it mean? It means showing the lower content or showing the higher content. Hold for options. So if I do a long click or press longer for something, you want something else, like secondary. So clicking something or pressing something, those are two different gestures, right? And then you have some general things which we'll discuss in a moment. Yeah, so let's talk about the, So different platforms have their own kind of guideline, and those guidelines change. So the new, for example, on the new Android, you will not see any of those icons, right? So you had previously a guideline which was sort of high quality rendered content, which, like, the speaker looked like kind of a speaker, right? But it's sort of textured and shadowed, and it is not, of course it's an icon, but the iconography is quite precise and quite realistic, right? If you first fast forward now, they use sort of a very iconic iconography. It's very dull in a sense, no much colors. It's sort of different to what it used to be, right? So the settings button used to be like this. You can feel, okay, it sort of reminds of some sort of physical gauge from some high audio equipment or something, right? The settings button, you know how it looks like. It's kind of like a gear. I don't see it here, but yeah, similar to this, like it's kind of a gear wheel, right? But it's very iconic. It's not very rendered, it's not shadowed, it's very plain, right? So Google went kind of a transformation from sort of a high quality rendered iconography to this one, and that one is called material design. And the fundamental aspect about it was that operating system and all the system level things are sort of the platform for hosting the user app and user content. And the user content and user app has to stand up, right? If the system level things are very neat and shiny and kind of eye-catching, then the user content will compete with that, right? And they didn't want that. They wanted the operating system and the iconography and things to kind of be in the background, to blend in, and the user app and the user content to kind of stand out. That's why they sort of moved away from the shiny, more high-definition iconography to this very plain, gray, and kind of blending iconography. The other thing is, like, even on PCs, you see the scroll bar disappearing, right? If you're not scrolling, the scroll bar is not there, right? Because there is a tendency for simplifying what you have in the background, what the operating system provides, to what the users build and for what the user kind of attention is being paid to. So Apple has exactly the same. You have to use the guidelines, right? Again, we don't have time to go into all the details. You have the links in the slides. You can at home browse it. So if you go to the Apple document, you will see that they kind of talk a lot about different screen sizes, different orientation, different arrangement of screens, how the components should work together, and you have kind of different principles, right? They talk about aesthetic integrity, the metaphors, and so on and so forth, and you can kind of read, you know, they document of how things should work and how things should look and how things should be utilizing the system properties that are there. If you go to Google, you have the same, but completely different, right? So they talk about their metaphors, they talk about their UI elements, which they kind of are stressing the layering, the kind of the paper design. It's sort of, the metaphor is that you have sort of sheets of paper which kind of stuck together, and they kind of are simplifying, like they went away from, as I'm saying here, they went away from showing things which are kind of a high quality 3D rendered features to something that looks kind of flat, right? Like on paper. So they went away from sort of like a physical material design, more to kind of a paper 2D type of things which are kind of stuck. So you have a depth, but it's kind of arranged by sheets. So the guidelines are there. They are for you to check. And depending for which platform you're programming, you have to take on board the guidelines. Of course, humans are the same. So humans using Apple or Android products are the same. They have the same fat fingers or small fingers and the same time perception and things like that. So that doesn't change. But what changes is the metaphors that are being used to manipulate the UI. And they are slightly different, right? So the physical principles, the attention principles, the psychology, and so on is the same. But there are some nuanced differences of how certain things are achieved and how certain things are done, right? So for example, I am using both. I'm using Android and iOS devices, and it really bugs me that there is no back button on iPhone, right? Sometimes it is. Sometimes in the left upper corner you have kind of a virtual button which lets you go back to the thing you just had before, right? But in a lot of apps you don't. And then it's like, how I get back to the previous thing, right? I don't want to do anything here. I want to go back to the previous screen I had. And often, I mean, it's not the problem of Apple itself. It's the problem of the app developer not giving me that virtual back button, right? But it's a kind of a failure. And that systemic failure is kind of mitigated in Android, because in Android you have the back button almost always. So you can kind of go back to the thing you just had before, right? So Google was sort of pushing that metaphor versus Apple saying, no, you just have home button, you can always go back home, right? And that's all you need. But that's not true. Sometimes you want to go back one level, and you can if the app is well designed, but if the app isn't well designed, you know, it doesn't work. But then again, you know, they will tell you if you need a back button, you should have it, right? It's in the guidelines that, you know, if there is sort of a pattern of usage where the user may want to go back to the previous screen, there should be this virtual back button. It's just that it's not enforced by the system. In Google, it is kind of part of the operating system. Like, even if you don't think about it as a developer, it's always there, because that's how the stacking of the activities work, right? So you have to make effort to break it. On Apple, you have to make effort to make it work, right? So, and then some developers don't do that. So there are small nuance differences But you know, if you're developing for Android, please read that document and kind of familiarize yourself of what it means to have an action button, where you should use it, how you play with the action icons on the top, how you do them on the bottom, where would you use it, and so on and so forth. We already had a break. So you can classify things with plethora of different axes, right? So here, for example, we have a taxonomy of different apps being classified of how serious or casual it is, and how, you know, entertainment versus utility it is, right? So games are kind of on the left on the screen, and tools are kind of on the right. So, you know, playful things, more serious things, you know, useful utilities, and casual versus serious. So, you know, you can have some sort of serious games, or you can have very casual games, and then you can have a very casual tools like, you know, flashlight, or you can have some text editing things, right? So why would you do that? Because then you can classify certain apps to certain categories and kind of see how they are published, and also what sort of UI usage patterns are being used, right? The usage pattern with casual means the app will be fired up, used for 15-20 seconds, and then stopped, right? So people don't sit down and work hours through a, you know, Bejeweled game, right? They are waiting on the bus stop, they kind of open it up, do a little bit, and put it in the pocket, right? But if they want to play kind of some strategy game, they can sit down and play for 15 minutes, right? They will spend more time. So the serious things means the app will be fired up and used for a longer period of time, whereas the more casual apps will be fired up, used briefly, for like, you know, I fire it up, check, oh, I don't have new messages, close it down, right? So then it doesn't make sense for a casual app to load a lot of resources, bootstrap everything, you know, you spend 10 seconds loading everything for the user to just check one thing for 5 seconds and close it down, right? It has to be, you have to work with timescales of what the user usage actually is. So that means we kind of splitting the use cases into some categories, right? So if you have a user, you want the interactivity with the phone or with the app to be, you know, sub-second if the user is pressing a button, right? You don't want any delays on that. So the actual reactions of the buttons and things have to be immediate, because that's what the user expects. So if I'm controlling anything or if I'm pressing anything, I want the feedback to be done immediately, right? But then I have kind of up to a minute things, which are kind of a short span, where I am checking kind of quickly how many messages do I have, you know, calendar entry. So things that should load almost instantaneously and should have the content right there. I shouldn't need to wait for, you know, I want to check the weather. I should not be forced to load the app and wait for the network connectivity to checking the weather and then telling me what the weather is. It should be pre-cached, right? So there are some things which are sort of in that second category, which I need to be being done in the background. So when I need it, it's there when I need it. So it's sort of a sub-minute category, right? And then you have the longer category. So in that category, I fire something up and I am okay waiting a little bit for the results to come back. And I can trigger things to happen in the background, you know, while I'm waiting for using the thing, right? So if I want to watch a movie, I'm okay for some buffering to take 10 seconds. If I'm gonna watch a movie for 20 minutes or even 10 minutes, I'm okay waiting 15 seconds for the buffering to happen, for example. But if I want to check something quickly, I don't expect to wait 10 seconds for something to load. So this is kind of a rough guideline. Again, it's not, it's just rules of thumb. It's not something, you know, every app makes sense to follow this, but most do. And especially with the UI, you have to guarantee that the interactivities are very, very fast. So what happened was in Android, you have the main thread, right? So everything you've done for lab 1 runs in the main thread. And when you press the button, like what Christopher did yesterday, he wrote a callback. When you're pressing a button, he was writing something to the logger. Remember that? He wrote a kind of a callback to the press of the button and said, write to the logger. All of that happens in the main thread. It's called UI thread. That thread controls the UI and interacts with the user, okay? So what people were doing, like let's say you write an app which says, load me something from a disk or fetch me something from the internet, right? So you have a UI, you press the button, and in the callback, it says, okay, now open the URL to this host, fetch me this image, process the image, and show the image to the user, right? So what will happen is you press the button goes gray because it's kind of activated, but it doesn't depresses. It's running the callback in the background, fetching the stuff for you, and then something will happen. But while it's happening, nothing happens on the screen, right? Why the button doesn't click back? Well, you know, that's called, that is called Android not responding, right? And because a lot of inexperienced programmers were doing that, Google said, okay, that has to stop. I mean, those things are just crap, right? So now when you're compiling your app and in your main thread, the compiler will detect that you're trying to access a file, trying to access a database, or trying to open a network connection, it will say, you cannot do that. You cannot do that in the main thread because you're very likely to run into the Android not responding problem because, you know, a user presses a button and the button should bounce back immediately, right? All your callbacks should be fast. If you need to fetch something in the background, spawn a separate thread, spawn a background thread which will do that, but give the user feedback immediately, right? So in the modern Android, the system itself prevents you to do some stupid things that end up with Android not responding error. I don't know whether you've seen that, like interacting with some apps. With the modern apps, it's not as common, but with the earlier Android, you had it a lot. Like you start something up, and then, you know, nothing happens, and after like 20 seconds or so, you have a pop-up saying, oh, this app is not responding, do you want to kill it, right? You don't see it that often anymore because the system enforces you not to do any networking, not to do any file access, and not to do any database access from the main thread. So if you want to do any of those things, which you will for the next labs, you have to actually do that in a background thread. You cannot do it in the UI thread. So that's kind of about the first rule, right? That the interactivity has to be fast. So most trivial things like buttons and drop-down lists and things like this are kind of dealt naturally. Where you will have this problem is, for example, with scrolling, right? So let's say you have an app. You have an app and you have a screen and you have a list view. So in the list view, all your elements are kind of items, right? So you have a particular item of the list, and this item can have an icon or an image, can have some text, and can have another image, right? So you may have kind of things like this, right? And then it has ability to scroll, right? And with scrolling, we like scrolling, so we would like to do this, and it's like scroll really fast, and I'm getting really down to the bottom to the number 200 on the list, right? But what has to be done is all those assets that I have to render, they have to be prefetched and kind of properly prepared, so then the scrolling actually works smoothly, right? And this is not easy. It is not easy if you have a kind of a list rich of content to be able to do it fast, right? So you've seen it. You see it maybe with the Facebook app or with Twitter, that you can kind of scroll through the messages, and at some point what will happen is you will get stuck and you will have this kind of progress button prefetching things for you. Like it will not scroll anymore, right? It will stop, it will prefetch the next, say, 100 items or something, and then it will allow you to scroll, but it will kind of get stuck again at some point, right? Because rendering all of this is, you cannot do it in real time. You have to pre-fetch things and pre-render things. So then the interactivity is smooth, right? You don't want like start scrolling to be jaggy, right? To kind of stop. right? When it's scrolling, you want it to be smooth, but when it cannot scroll, you want this to get stuck, right? You want to prevent the getting stuck. So while the user is scrolling, you often do the kind of a preemptive like calculations of how likely it is that the user will scroll under the next buffer that I have. So then you prefetch that before the user reaches that, right? But sometimes the user scrolls so fast that you cannot do that. And then you get stuck with the progress bar. All right. We are running out of time, and I actually didn't get to the point of the lecture, right? Of the view groups and of the layouts. So what we could do is, okay, I still have 3 minutes, so let's do it really fast. And then what we will not manage, we will do on Thursday, okay? So the point here is that we, yeah, maybe we leave it till Thursday. Yeah, okay. All right, so let's do it on Thursday. This is sort of organizing the UI and why we're using XML and how you link the code with XML. So this is a little bit what Chris did yesterday, but with more details. So yeah, so we will finish for now, and we will do it on Thursday. So thank you very much. If you have any questions. Okay, thank you.
In Akon was very good. It's very, very, very right. Classical.